Hello, valued viewers. I hope you're all doing very well. And just a quick, gentle reminder that the Super Thanks button is on. Any contributions to the channel's effort is greatly appreciated. And if you want that custom video, contribute $20 toward the channel's efforts, and you get a topic of your choice, just go to the comment section, let me know what you want, and that your project takes priority over anything I am doing at that time. And with that, let's get on with the video, the top 10 worst steam locomotives of all time. Enjoy. Let me just start right off the bat by saying that this list was far easier to compile than the 10 most successful steam locomotives of all time. So with that, let's get going.
Number 10. The Pennsylvania Railroad S2.
Okay, so if we were talking about the best looking steam locomotive of all time, this might be number 1, but we aren't talking about that. Okay, so this locomotive was troubled from the start. In reality, it probably shouldn't have been built at all. So originally the design was supposed to be a 484, which would have had it fare a lot better than what it wound up doing. So they didn't go with the 484 design because allegedly the War Production Board was limiting the cast steel alloys that was needed to make that frame. So instead they went to a 686 design, which used lesser quality alloys. And then, of course, it utilized steam turbine technology, which was still brand new and relatively untested, even though the Pennsy had the most experience using that type. And mechanically, it was still very bugged and very troubled in that regard. But the worst thing about the S2 was its sheer size. The length of the locomotive and tender was 122 feet, and for comparison's sake, that size actually almost meets the B&O Railroad's EM1 Yellowstone. And at 1,032,000 pounds, the S2 actually outweighed the B&O's EM1 Yellowstone. To go along with that, the locomotive did not perform the way it was supposed to under 30 miles an hour. In fact, it cost way more to operate a conventional steam locomotive at 30 miles an hour and below than it was the S2. And then you have the Pennsylvania Railroad speed restriction of 50 miles an hour on a majority of its lines. And unfortunately, the S2 hit peak performance above 50 miles an hour. But above 50 miles an hour, the S2 actually outperformed conventional steam in regards to the cost of consumables and whatnot by a wide margin. The S2 was just never able to be used the way it was intended to be used because of these restrictions and also, of course, the maintenance problems of the turbine. And then, of course, you have a 122-foot overall length of locomotive on a rigid frame on a curvy system. Now, I will submit that if you added roughly 5 feet or 6 feet to the design so you could articulate the front bogie of 6 wheels, then it's an entirely different locomotive altogether. And a very intriguing one at that as far as performance is concerned. But that didn't happen, and so the S2 is my number 10 least successful steam locomotive.
Number 9. The Santa Fe 1158 class jointed boiler.
Okay, first of all, when it comes to this locomotive, I have a video coming out describing this one in detail, so stay tuned for that. Okay, so in early 1910, the Santa Fe crew at their Topeka shops manufactured the Santa Fe number 1157, and this was a 2662 articulated locomotive fashioned together from a pair of 262 Prairie locomotives that were owned by the Santa Fe, and those Prairies were numbers 1051 and 1125. In designing the locomotive, the decision was made to incorporate a jointed boiler. So what was great about the jointed boiler from a physics standpoint was that the new design would allow for the weight of the boiler to be better distributed as it was attached to both trucks. The expectation was also that the locomotive would provide less wear and tear on the tracks and provide a smoother riding experience. So the Santa Fe built 2 of these locomotives, which were the 1158 and the 1159. Like the number 10 locomotive, the S2 from the Pennsylvania, Santa Fe's 1158 and 1159 had decent careers for the Santa Fe, but both were scrapped by 1930, which gave them just under a 20-year career. And ultimately, the railroad realized that the design did not come close to producing the benefits that the company had hoped to see, especially given the cost of building and maintaining these locomotives. Ultimately, the fact that the design was limited to the Santa Fe and 2 total locomotives is the best indication that the locomotive wasn't very effective. However, it is the unique part of steam history worth remembering from the creativity alone. Santa Fe historian E.D. Worley bluntly stated, "One can only stand in open-mouthed admiration of the vast dissipation of mechanical talent implicit in the accordion-style pleats. Pure conjecture is quite insufficient to visualize the thousands of lost machinist and boilermaker hours that were doubtlessly wasted to keep these mechanical abortions on the road." And well, there you have it, folks. My number 9 least successful locomotive, the Santa Fe 1158 class.
Number 8. England Southern Railway Leader Class.
Okay, so the Leader class was an experimental steam locomotive produced in the United Kingdom to the design of innovative engineer Oliver Bolide. The Leader was an attempt to extend the life of steam traction by eliminating many of the operational drawbacks associated with existing steam locomotives, and was hoped that these designs would be a direct replacement for the aging fleet of M7 class tank engines still in operation on England's Southern Railway. And needless to say that the program was overrun by cost developments and mechanical reliability on the design itself. So following trials that lasted over a year, the number 36001 was shown to have several flaws, including heavy coal and water consumption, mechanical unreliability, untenable working conditions for both firemen and the driver, loss of steam through the cylinder rings, and uneven weight distribution on the bogies. So needless to say, the Leader bombed on just about every worthwhile metric. Folks, this is kind of how bad this design was. Some of the firemen allotted to the Leader complained about cramped conditions in the center cab of the locomotive, and this situation was made worse by flames entering the cab from the firebox at high outputs. And it was a unbearably hot cab on the whole as well, because they measured temperatures while under operation at 120 degrees Fahrenheit. And the crews over there running those locomotives called these locomotives the Chinese laundry due to the heat and humidity. So after the trial runs in 1950, in November of that same year, the 36001 and the 4 other locomotives that were under various stages of assembly, they were all cut up and scrapped, and the whole project was basically thrown out. So that's my number 8 least successful locomotive, and you can argue that it should be higher on the list. I put it at number 8 simply because it was never really produced. They just had a trial locomotive with 3 others under construction.
Number 7. The Baltimore and Ohio Emerson N1 Class.
Okay, so the Baltimore and Ohio Railroad's N1 class, also known as the George H. Emerson, it was the first duplex locomotive and the first 4444 locomotive ever built. It was designed and built by the railroad's own shops in 1937. So you know when you have a first at everything, you're going to have a lot of problems. But I will say this for the locomotive, like the S2, if I was doing the top 10 best looking steam locomotives, this will certainly be on it, and probably in the top 5 to maybe number 3. But once again, we aren't doing that. Okay, so in this Emerson locomotive, the rear set of cylinders were placed beside the firebox. This allowed the locomotive's wheelbase to remain the same. However, the space beside the firebox was hot and dirty, which caused premature cylinder wear, and the placement of the cylinders limited the size of the firebox. These same problems occurred with the Pennsylvania Railroad's Q1 class, which also placed the rear cylinders by the firebox. It was built by the B&O's own Montclair shops in 1937. However, it had problems with the sizes of the cylinders facing the other direction. So the basic premise behind the Emerson design concept was to develop a more powerful rigid frame locomotive that used 2 sets of powered drivers instead of 1. And in theory, this would reduce maintenance since it used lighter and smaller main rods, unlike the Pennsylvania Railroad's Q1 design by comparison, which advanced the design further than any other company, and it's most often associated with the duplex drive. The B&O's approach was a bit different by locating the back cylinders nearest the cab and under the firebox behind the rear drivers. And this setup turned out to be the locomotive's glaring issues among others. By placing the cylinders under the firebox, they had a tendency to overheat and as well collect dirt and dust, as we noted before. And besides the cylinder problems, the locomotive also experienced problems related to its bearings that constantly kept it sidelined and in the shops. Perhaps in time the B&O would have ironed out many of these setbacks, but interest in the steam locomotive's development was waning as diesels proved they were capable of mainline power. So basically all the problems during trials, the Emerson sat idle during the 1940s, and in 1950 it was finally scrapped. So that is my number 7 locomotive, the N1 class of the Baltimore and Ohio Railroad.
Number 6. The Pennsylvania Railroad's Q1 class.
So the Pennsylvania Railroad's Q1 class was a single experimental steam locomotive designed for dual service. The locomotive entered service in 1942 and was retired in 1949 after accumulating a relatively low 165,000 service miles. And like with any of these experimental designs, there were numerous mechanical issues on the Q1. So the Q1 spent a considerable amount of time in the repair house. And also, the Pennsylvania Railroad itself considered the Q1 design unfit for series production, and railroad historians considered it mostly a failure as well. And for starters, the backward driving rear cylinders were a poor choice because they were mounted next to the firebox, each constrained the other's size, and the area of the firebox was dusty and hot, which increased cylinder wear. And like we spoke of with the Emerson locomotive of the B&O, these problems had previously been encountered with that specific locomotive. The length of steam pipes required also meant a fair degree of power loss. Added to this, the passenger locomotive-sized drivers were not very well suited at all for freight service. So as earlier mentioned, the locomotive only had 165,000 miles of usage because of the maintenance problems, and also it was impractical to run. So after roughly 7 years of service altogether, it was scrapped in 1952 and withdrawn from service in 1949. So that's my number 6 locomotive, the Q1.
Number 5. The Santa Fe Railroad's Class 3002 1010 double-decker pod.
Okay, so folks, this class I really wanted higher on the list, but as it works out, it's actually kind of well suited right here at the number 5 spot. And I wanted it higher because you would have thought that the Santa Fe would have learned the lesson from the 2662 Mallet kit bashing that they did with this double-decker pod kit bash. And well, that just wasn't the case. But we can say this, the Santa Fe workshops were nowhere near the likes of what the Norfolk and Western and the Pennsylvania Railroad shops turned out to be. And I think rightfully so, the Santa Fe got out of the articulated locomotive designing business. And basically, the failure of this 210-10-2 kit bashing idea was simply because they didn't think to enlarge the firebox and or the fire grate area to produce, steam power, because the locomotives simply ran out of steam trying to run mainline type operations. So basically they were just limited to helper service because of the steam problem. So between 1911 and 1912, the Santa Fe Railroad basically modified 10 210-2 Baldwin-built locomotives into the new double-decker pod configuration, and they were dubbed the 3000 class. At the time, they were the largest locomotives in the world from their introduction until 1914. They did reasonably well in this helper service, as I mentioned, but they could only go 10 to 15 miles an hour, and then they just simply lost steam power. They were so bad with the steam loss that the Santa Fe basically returned them to their original 210-2 configurations between 1915 and 1918. And subsequently, the Santa Fe quit with the articulation business altogether until the 1940s. So that's my number 5 locomotive, the 210-10-2 double-decker pod locomotive Series 3000 from the Santa Fe.
Number 4, the Pennsylvania Railroad S1 class.
So folks, I've already established that the successor of this locomotive, the S2, was some 122 feet long. Well, get a load of this one. This locomotive was 140 feet, 2.5 inches long, which makes it 8 feet longer than a big boy. So if I thought articulation should have been used on the S2, it definitely should have been used on this locomotive. And of course it wasn't, hence problem number 1 of a serious nature. And this one, more than any other PRR, definitely falls under the category in my book of what the heck were they thinking. And also, this locomotive had the largest passenger driving wheels ever put on a locomotive, 84 inches or 7 feet in diameter. Just unreal. So given that we've also established that the Pennsylvania Railroad's lines were really curvy and whatnot, you think this thing is going to navigate those curves? Not so much. Simply stated, the wheelbase was way too long for the curves on this line. So basically, because the S1 was so large, it could not negotiate the track clearances on most of the lines on the Pennsylvania Railroad system. So in its brief service life, it was restricted to the main line between Chicago, Illinois and Crestline, Ohio. It was assigned to the Fort Wayne Division and based at the Crestline Engine House. And because of that fact, and also the fact that they spent just over $14 million on this single locomotive, which is the most expensive I've found so far. They just didn't get any bang for the buck out of this thing. Mechanically and maintenance-wise, there wasn't a whole lot of complaints about this locomotive. A lot of the engineers actually liked the thing. The problem was it just couldn't negotiate the curves. So really, if they would have just articulated this particular locomotive in particular, the outcome of this thing might have been really different from what it really was. So that's my number 4 least successful steam locomotive.
Number 3, the Chesapeake and Ohio M1 locomotive.
Okay, so this is another one of those aesthetically pleasing locomotives that turned out to be not much of anything otherwise. So the Chesapeake and Ohio M1 class was a fleet of 3 steam turbine locomotives built by Baldwin Locomotive Works for the C&O Railroad in 1947 to 1948 for service on the Chessie Streamliner. And correct me if I'm wrong, but I believe at 154 feet long, this was the longest locomotive ever built. Okay, so the first problem was the fact that it was a steam turbine locomotive, which has never been tried by a U.S. railroad, let alone the Chesapeake and Ohio, and yet they ordered 3 of these things instead of just a prototype of which they should have started with, and then they would have saved, a huge chunk of money. Folks, the C&O Railroad paid $42 million for the 3 of these locomotives. So, folks, the C&O Railroad paid, in today's money, $42 million for the 3 of these locomotives. And what they really got was something that was way overcomplicated for the average engineering crew to handle. And also, the thing was always broken down. It was broken down more than it ran. It took days to find problems and then hours to fix the problem. And on top of that, the M1s proved to be way too expensive to run, and they were mechanically unsound and unreliable at most of the time. And basically, I don't have to say anything further about this. It is what it is. So if you care to, just be like me, scratch your head and move on. All right, so that's my number 3 locomotive, the M1 for the Chesapeake and Ohio.
Number 2, Soviet Railways AA-20.
The Soviet Railways AA-20 is simply an unmitigated disaster for standard steam locomotive technology. And really, in my mind, the idea principle really had more to do with ego and outdoing the Union Pacific's 9000 class locomotives than it did for practical use. So in a nutshell, this particular locomotive ate Soviet Union trackway for breakfast, lunch, and dinner. It wrecked switch points, it spread rails further apart, it was derailed all the time, it pulled couplers out, it ran out of steam so fast at full power, but otherwise the thing was fine. The locomotive itself was so rigid they couldn't even get it to round curves, and they tried blanking over flange wheels and what have you, and to no avail. The thing was basically useless. And to that point, the thing sat in storage for 25 years before it was finally scrapped in 1960. Enough said, the AA-20 was an unmitigated standard steam locomotive disaster. And it's why it's my number 2 worst steam locomotive design ever. And my number 1 worst steam locomotive design ever built was the Erie Triplex. Needless to say, the Erie Railroad quickly noticed the triplex had several issues while in service and surely would not have been able to move the 600-plus car freights as Baldwin had predicted it could. First of all, the locomotive literally exhausted all of its steam in a short amount of time if it operated at speeds greater than 10 miles an hour. Second, since the last set of drivers was under the tender, the unit's factor of adhesion was slowly reduced as the coal and water was consumed. And lastly, the locomotive produced so much tractive effort the drawbars, couplers, and freight car frames of the era could not withstand the prodigious levels of strain being asked of them. So similar to the Russian AA-20, the triplex has basically caused more damage than anything else. And basically the only thing the triplexes could be used for was basically pusher service. You could make an argument to swap the Russian AA-20 out with the triplex as the worst design and performing steam locomotive ever, but I went with the American simply because we as a nation were far more advanced as far as designing and developing steam locomotive technology, and to have a catastrophic failure such as this triplex is just simply unforgivable in my book. So therefore, I put the triplex in the number 1 spot for the worst design and performing steam locomotive ever. And there you have it, folks. I hope you all enjoyed the video, and if you did, leave a like, and also don't forget to subscribe if you haven't subscribed to the channel yet. Both features help the channel grow immensely, and we thank you for watching.